Hello friends, welcome back. Hearty welcome to you. In this session, let's try to understand how to differentiate implicit functions. Just before going into the differentiation of implicit functions, let's understand what are implicit functions. So, if you till now whatever the functions we have seen, all of them are like one of these. We have y equal to x, or we have y equal to e power x, or we have x square plus a power x, or we have sin x plus x cos x, or we have cos x into e power x. So we have, these are all different examples of the functions for which we have found the derivatives till now. You can look here, we are able to write here y as term as a function of x. That means on the right hand side we have only x terms, nothing else. But sometimes the definition of the function will be such that we know that the y is a function of x, but we cannot write it as explicitly as y equal to f of x. We can only write it as in the form of another function which will have x comma y terms and equal to 0. Then this function is called as implicit function. An example of implicit function is x square plus y square plus 2xy equal to 0. Now let us try to see whether I can write this function as an explicit function. Now what happens? I have y into y plus 2x equal to minus x square, or you can see that y equal to minus x square by y plus 2x. So you can see that when you try to write down y equal to f of x, you end up with f of x comma y. So these functions are called as implicit functions. Now how will you differentiate the implicit functions? Let's have a look at that. Till now we are trying to find the derivative of x square. We are very comfortable because we know d by dx of x square is, we have to apply the power rule, and it will become n into x to the power of n minus 1. That's equal to 2x. Now how to find out the derivative of y square? So we know that y is also another variable like x, so we can say it's apply the same formula 2 y to the power of 2 minus 1, but in addition to what you have earlier, you will also have dy by dx with you because you are differentiating y with respect to x. Or can we write it as 2y y dash, where I can say y dash is equal to dy by dx for simplicity. So remember that whenever you are trying to differentiate a term, whenever you are trying to differentiate a function which is having y like y square, e power y, or x or y cube, so you remember that you will find the derivative, and with the derivative you also will be writing nothing but dy by dx because you are differentiating y with respect to x. Whereas when you do differentiating of x with respect to x, it will become 1. That's why it is 2x, whereas here it is 2y y dash. So with this little bit of understanding, we should go ahead and try to solve one simple example how to do. Let us try to solve this example by using implicit functions. We have x cube plus y cube minus 3axy equal to 0. So we said that whenever we want to find out the differentiation of implicit functions, we'll differentiate on both the sides. So we have to do differentiation of all the terms on left side and also all the terms on the right hand side. We know right hand side differentiation of constant is 0. So I have step by step, I'll write it down. I have first d by dx of, because we know y is a function of x, we are treating it as a function of x, so we want to find out. So this will be d by dx of x cube plus y cube. That means I have to find out d by dx of y cube minus 3a into d by dx of xy. d by dx of x cube, so I'll be using power rule, which tells me x by d by dx of x to the power of n is equal to n x to the power of n minus 1. So I can write it as 3x square plus d by dx of y cube. If you remember with our discussion, we will have 3y square. Not only that, we will have dy by dx, which is nothing but equal to y dash. We can take it as y dash for simplicity. Y dash minus 3a into d by dx of xy. Here we have to use uv formula. Derivative of uv or uv dash is equal to u into v dash plus v into u dash, or you can also write u into dv plus v into du. So that becomes x is u, x into v dash is dy by dx, can I say y dash, plus v into u dash, v is y and u dash is dx by dx, that's equal to 1. So y into 1 equal to y. Now we can take out 3 from all the terms. I will have x square plus y square y dash minus ax y dash minus ay equal to 0. Or now next step will be, we want to find out the dy by dx. So I will keep all the terms of dy by dx on one side. It will become y square y dash minus ax y dash is equal to ay minus x square. Or can I take y dash common and write it as y square minus ax is equal to ay minus x square, or y dash or dy by dx is equal to ay minus x square divided by y square minus ax. So the point we have to understand, this is a simple example where we try to find out the dy by dx when the function is given by x cube plus y cube minus 3axy is equal to 0, which is an implicit function because you cannot write it in terms of y equal to fx explicitly. So we have differentiated that. Now remember that till now we are only dealing with the derivative of x terms related to x, but now we have x and y combined and y also. So remember, whenever you are dealing with y, you will have the derivative and also you will have y dash with u, which is nothing but dy by dx. So derivative of x cube is 3x square, derivative of y cube is 3y square y dash. Then x and y are in the form of u and v. So you apply the formula uv dash plus v into u dash. You can simplify that. Now always our last step will be take all the terms which are having y dash on one side and the other terms on the other side and divide, so that you can get the value of y dash or dy by dx equal to ay minus x square by y square minus ax. Let's look into one more interesting example. Let's look at one more implicit functions. We have been given y equal to x into sin y. We have to find out what is the dy by dx. So how will we do this? Again, we know that this is implicit function we see there, and for all implicit functions our approach is to differentiate on both sides. So can I say dy divided by dx is equal to d by dx of x sin y, x into sin y. Again you can see that we have x is u and sin y is my v, and I know uv dash is equal to u into v dash plus v into u dash. So let's go back to the next step. When you want to differentiate on both sides, dy by dx will remain as dy by dx only, is equal to d by dx of uv, so that is u is x into v dash, sin y derivative, that is nothing but d by dx of sin y plus sin y, that is v, into u dash d by dx of x, which will give us dy by dx equal to x into d by dx of cos y is equal to x cos y. Derivative of sin y is cos y. And remember, whenever we are having terms with y, we will have dy by dx with us. It becomes cos y dy by dx plus sin y into dx by dx, that's equal to 1. Now if you try to keep all the terms which are having dy by dx on one side, we'll have dy by dx into 1 minus x cos y is equal to sin y. Or can we write dy by dx is equal to sin y divided by 1 minus x cos y. So we have solved another example which is very simple. Implicit function, how to differentiate. So remember, whenever we are having terms with y, after the derivative you will have dy by dx. This we should be pretty much clear how we are doing that. Then it should be pretty easy. Let's look at one more example. Let's try to step up a little bit and go to next level of examples. We have been given log of root of x square plus y square equal to tan inverse y by x. We have to find out the value of dy by dx. We have to find out what's the value of dy by dx. So what we will do now first is, we know that we have to differentiate on both sides because we see the implicit function there. So my first step will be, what will be my first step? My first step is to find out the derivative of d by dx of log of square root of x square plus y square. This is equal to d by dx of tan inverse of y by x. Now we know that derivative of log function is always equal to 1 by x. We know that d by dx of log x is equal to 1 by x. So we will write down 1 by square root of x square plus y square. Then after that we have to find out derivative of root of x square plus y square. That's equal to derivative of tan inverse y by x. Tan inverse x derivative is 1 by 1 plus x square. D by dx of tan inverse x is equal to 1 by 1 plus x square. So I'll write down, for tan inverse it is 1 by 1 plus x square. X is y by x here, so that is y by x whole square. Then I have d by dx of y by x. Let's write the next step. The next step will be 1 by root of x square plus y square, and after that we have d by dx of root x. Root x derivative is 1 by 2 root x. That's nothing but 1 by 2 root x square plus y square, and I will have here d by dx of x square plus y square. And if I simplify here, I will have x square by x square plus y square, and we have d by dx of y by x, which is nothing but equal to, again, u by v formula, that is equal to v square, and I have v is x, and u dash is nothing but v is x, u dash is y dash, minus u, that is y, into v dash, that is equal to 1. So let's go to the next step. Next step, if we simplify this, we'll have 1 by root of x square plus y square into root of x square plus y square becomes x square plus y square. So can I say it as 2 into x square plus y square, and d by dx of x square plus y square is 2x. We know derivative of x square is 2x, and y square, the derivative is 2y y dash. I hope you are comfortable by this time with that. the derivative of x square is 2x and derivative of y square is 2y y dash. And on the right hand side we have x square by x square plus y square, and I have to multiply that with x y dash minus y. Y dash is nothing but dy by dx, please remember that, divided by x square. So I can cancel x square, I can cancel x square plus y square, I can take 2 there common out, then it will become 2 into x plus y dash divided by 2 is equal to x y dash minus y. Can I cancel 2 also? My next step will be x plus y is equal to x y dash minus y dash, or can I say x plus y is equal to y dash into x minus y, or y dash is equal to x plus y by x minus y. So that's how we can find out the derivative of the implicit function, which is log of root of x square plus y square is equal to tan inverse of y by x. Then what is the value of dy by dx? In the next video we will do some more examples on implicit functions. So let me try to summarize how to do the differentiation of implicit functions. So when we want to, first of all, what is implicit functions? A functions in which you cannot say y as a function of x explicitly. You cannot say like y equal to x square plus 2x or x square plus sin x or e power x plus x cos x. You cannot say in terms of x, but when you want to say y, it also involves y terms also, like x square plus y square plus 2xy equal to 0, or x cube plus y cube plus 3axy equal to 0, or for that matter the example what we have seen just now, log of root of x square plus y square is equal to tan inverse of y by x. In this type of implicit functions, to differentiate that, we will differentiate on both left hand and right hand side. We will treat y, the variable, as also like how we do differentiation with x, but only remember, whenever you are trying to find the derivative of a term of y, like y square or e power y or sin y, remember after the derivative of sin y, if it is suppose cos y, you will also have dy by dx or y dash attached to that. So that's how you just proceed. You just follow the chain rule, and whatever the concepts we have learned till now can be leveraged to find the differentiation of implicit functions. In the next session we will see some more examples on the implicit functions. Thanks for your time and support. Bye for now.